Hello, and thank you for clicking on the help video. In this example, I'm going to help you answer the following two questions. How long does it take for the soccer ball to reach its maximum height? And what is the maximum height of the soccer ball or what is the maximum height of the soccer ball will reach? Now, given that this equation represents the position of the soccer ball, all right, h obviously represents the height, which is just your output value, and x, as stated right here, represents the time in seconds. So for the first part, how long does it take for the soccer ball to reach its maximum height? We're looking for essentially the x value of the vertex. So since we are already identifying this as a maximum, we should automatically understand that this parabola is going to open downwards for, well, one, it's telling us that it's a max. So in order for it to have a max, it has to open downwards in order for this vertex to be the highest point. And the second reason I also know is because this value right here of a is a negative number. Now, you could jump straight into Desmos and look at the graph of this thing, and you can identify again the x and the y value. So our maximum height is going to be at 2.125 seconds, and the maximum height is 76.25. I think the unit of measurement is in meters. Let me double check. Oh, in feet. It's in feet. So feet. So at least I know the decimal value of that. But again, we're not too sure if that decimal value doesn't repeat. So again, let's know how to do this without jumping straight into decimals. So to figure out the x value of that vertex, we're going to use the same formula that we used to find out the axis of symmetry. X equals negative b divided by 2a, where the value of a is this negative 16, the coefficient to our x squared, and the b value is the coefficient of our x term. So plugging those values in, we're going to get negative of negative 16 divided by 2 times a, which is 68. And let's see what we end up with. So I'm going to plug that into the calculator. That I can do, all right? So let me hide that because I don't want that to influence me. So we want to do first a fraction. So the negative of our b value, which is positive 68, and we're going to divide that by 2 times our a value of negative 16. And we get that decimal, which when I convert it into a fraction, is 7 over 8. So, oops, I wrote this backwards. I wrote it backwards here, but I wrote it correct on the calculator. So 68 goes on the top and negative 16 go on the bottom. So 7 over, what did I say? No, 17 over 8. 17 over 8. So that's the time. So it's going to take 17 over 8 seconds, or again the 2.2 seconds. So x equals to 17 over 8. So that's how long it's going to take for the soccer ball again to reach its maximum height. Now, what is that maximum height going to be? Again, with decimals, we see that the decimal equivalency of that is 76.25. Let's see what the fraction value of that is. And the reason I'm not just typing in 76.25 and converting it into a fraction is because I'm not sure if that 25 is the end of the decimal. It could be that because again it's such a large number or big or weird number that there's more decimal values after that 5, or maybe even the 25 is repeating. So again, this is why it's important to have a backup plan and know how to do this by hand and where we're getting these numbers and how to get these numbers without jumping straight into the graph itself. So let's go over how to do that. So the way we get out the y value here, that decimal of 76.25, is by now to plugging in this number into this equation. Thus, let's substitute that value in again for those x's for x. And let's see what this equals. So we have negative 16. We're going to replace again the x value with that 17 divided by 8. Again, I don't want to use the decimal because again, I don't know. Well, in this case, I could use that decimal, or I'm not too sure because I don't know if that decimal again ends right there. It could be that there's more decimal values after that 5, or maybe the 0.125 is a repeating decimal value. I can't just take it for granted and assume that it ends at that 5. So let's raise this to the second power. We're going to add the 68 again, replace the x with the 17 over 8, and then add the 4. And again, we get that 76.25, which as a fraction is 305 over 4, okay? So, and you're asking, well, again, didn't I just write that? But yes, okay, yeah, you did write that there. But because we're writing in the fraction notation, this decimal value, even though there's might or might not be more numbers after that 5, is already taken into account by the calculator. So when I convert this answer that I got, 76.25, into a fraction, it automatically considers the fact whether it terminates or repeats what the actual value is. So my actual value as a fraction is 305 over 4, which again is the same number if I type in 76.25. So there was no repeating value. This 0.25, again, the 5 was in fact the last number in the decimal, and nothing was repeating. But again, I can't take it for granted and assume automatically that just because I get it from right there. This again will tell me where the location is, but in case where the decimal values goes on forever, obviously the calculator, the computer is not going to continue doing that because it's not going to ever end, and it's going to again malfunction. So we can't just assume that that decimal value is the last decimal value in these for these numbers. So again, backup plan is to use again and know how to get these numbers without, like I said, jumping straight into the graph. So 305 divided by 4. So this is going to be again the actual height itself. And for these, you don't have to write x equals or y equals. Like I don't have to include that part on the homework, on the entry box. You don't have to write it as an equation. You just simply need the number. So here I need that number in purple, and then this number in purple for the second answer box. So that concludes again this example. I hope you found this video helpful, and I appreciate you watching.